Everyone, and welcome to today's webinar, Power over Ethernet, New Features and Capabilities, presented by Electronics Weekly Webinars in partnership with DesignSpark and ON Semiconductor. Hello, my name is Clive Coldwell. I'm the Group Editor of Electronics Weekly, and I'll be your moderator for today's session. I'm pleased to introduce today's speakers, Mike Sandick and Joris Lemahieu. With long-standing experience in the electronics industry, Mike recently joined ON Semiconductor as Product Marketing Manager. With a past in industrial automation and IoT applications, switching with engineering support and product marketing of semiconductors, he couples an acute business sense to advancements in technology. Mike holds an industrial engineering degree specializing in microelectronics from Hodge School, I hope I pronounced that correctly, in Ghent, and a master's degree in information and computer technology from Thomas More Hodge School in Kempen. Joris Lemahieu is an applications engineer in the Energy Management Business Unit at ON Semiconductor, based in Oudenaarde, Belgium. He is the specialist in Power over Ethernet products and solutions, and he's also worked as a hardware development engineer and field application engineer. Joris holds a master's degree in electronics engineering technology from the Ghent Technology Campus and an MSc degree in electronic engineering from Ghent University. But before I hand over to Joris and Mike, I have a few housekeeping items to cover. First, today's webinar will be available on demand after the live session, and it's accessible through the same link you're using now. Next, we'd love to hear from you, of course, during today's presentation. So if you have a question for our speaker, please feel free to send it through the Ask a Question tab at the bottom of the page. We'll be holding a Q&A at the end of the session, and if we don't get to your question during today's webinar, we'll be sure to follow up afterwards. And finally, we'd like to encourage you to share today's webinar with your social networks. So without any further ado, I'd like to kick things off by welcoming Mike Sandick and Joris Lemahieu. Thank you, and over to you, gentlemen.
All right, thank you, Clive. From our side, welcome to the webinar as well. I will be briefly giving an introduction and then hand over to Joris, as I'm too new in the matter to cover it completely, and moderate the questions and answers for you. So we'll keep it briefly today, covering first what is new in the PoE standard, and then follow that by which solutions ON Semiconductor can provide for you. So if you keep your questions for the end of the session, or pose them, type them out as the session progresses, we'll come to them at the end of the webinar. So without further ado, I then hand over to Joris.
Thank you, Mike. This is Joris. I'm the application engineer and specialist in Power over Ethernet products. And I'll guide you to the technical details and how to implement a PoE solution. So Power over Ethernet, or short PoE, is a technology that already exists during many years. And the main benefit is that it allows you to deliver power next to the data over existing Ethernet cables. In September last year, the new 802.3bt standard was released. And with this new standard, it will allow you to make a system that is powered over the Ethernet that has a lot of more power capability, up to 90 watts. So with this new 802.3bt standard, a lot of new applications will be possible, and it is expected that the full release of the 3BT standard will be beginning next year. It will be very soon, so if you want to be in the forefront, it's the time now to start your design. So first, I would like to begin with an introduction to Power over Ethernet, because before telling what is new, it's important to know what the basics are, because those still hold. So how does a PoE system look like? So first of all, you have a certain device that you want to power over the Ethernet cable, and that device, in terms of power over Ethernet, is called a powered device or a PD. Then, of course, you have an Ethernet cable. This is just the regular Ethernet cable that is used for data as well, so you do not need any special requirement for the Ethernet cable. You just can use the same as the one that's used for data to transfer power as well. And then, of course, you need a power source, and in terms of PoE, this is called the PSE, which is short for power sourcing equipment. And of course, that PSE incorporates AC to DC converter, and the PSE will be powered from the grid, so you will need the grid cable as well. So basically, just a PoE system consists of 4 components, and it's easy to be set up and use because it's a worldwide standard that guarantees interoperability, and it's very easy to deploy. So then I would like to focus on how PoE works, how actually the power is transferred between the PSE towards the PD over the Ethernet cable. So the Ethernet cable that's used is a regular Cat5 or Cat5e cable. Better cabling is possible, of course, as well, like Cat6 or even better. But Cat5 is the basic one, and as you know, Cat5 cable contains actually 4 twisted pairs. And the power is transferred over 2 twisted pairs at the same time. And there are basically 2 modes that can be used. The first mode is called alternative A. And in that case, the power is transferred over the same cables that are used for the transmit and receive of the Ethernet data in a 10100 megabit Ethernet system. Of course, the question that pops up is how is this done, because how can you combine power and data? And the trick is here that the power is transferred in a common mode kind of way, whereas the Ethernet data is differential. So in this mode, you have in the means you use to inject and subtract the power from the Ethernet cable is to use the center tap of the LAN magnetics. And with this, you can combine power and data. The other option to use is alternative B, and in that case, in case of a 10100 megabit Ethernet system, you use the spare data pairs that are not used for transferring the data. So in that case, you can inject the power directly onto the cable. But it's also possible to use PoE in a gigabit Ethernet data system, and then of course in that case also on alternative B there will be a center tap of a transformer that needs to be used. Then how is the power transferred, and what are the characteristics? So basically, in the PSE, the power supply is a DC voltage source. The voltage level is around 54 volts, so a bit above the more common 48 volts. And the reason why using a high voltage is because it allows for a higher efficiency power transfer. But still, PoE wants to be a safe system, and that's why the voltage is always kept under 60 volts, and the limit, according to the standard, is 57 volts. What's also very important to know is that you can use PoE for a distance up to 100 meters. So basically, you can, the PSE could be on one end of a soccer field, and the PD could be at the other end, and there will be no system, not any issue delivering power to that device. So, of course, when you incorporate 100 meters of cable, it could have some significant resistance, and this all has been taken into account in the Power over Ethernet standard. But it also makes that you need to be aware that the power rating of a PSE and PD will be slightly different, because the PoE technology also incorporates the worst case cable losses. So the first generation of Power over Ethernet, that's called 802.3AF, that allowed up to 13 watts of usable power for the power device. Of course, the PSE had to be able to deliver slightly higher power due to the losses in the cable. Then with the second generation of Power over Ethernet, according to the 802.3AT standards, the PD power level could go up to 25.5 watts. And now with the new 3BT standards, the power level can go up to 71.3 watts. That's for 100 meters of cable, but for short cable distances, you can go up to 90 watts of power. So that's really a significant improvement. What's also very important when designing a Power over Ethernet system is that the current and the power is limited, and the PSE will accurately monitor the current and or power consumption. And it's important when designing a system that you keep or design the system as such that you do not go over the power constraints, because otherwise the PSE will just disconnect the system, which is unlikely in almost any case. So also what's important to remember is that when talking about the power level, then of course the power level can and will be different at the PD input, the PSE output, and also the power ratings that will be used here during this presentation are typically the actual power that can be used, so that's measured at the PD input. But of course you still have to take into account that there will be some losses due to DC-DC conversion. So when making a system, the useful power that can be used is then given there in the table on the right for 90% efficiency. Of course, you can increase that power value by using a higher efficiency DC-DC converter, but it already gives you a good idea of what systems can be powered from over a PoE system. Then the power is just not immediately applied to the system, because that would be not safe and it could give issues. So there's a process that is followed, kind of an algorithm. So the first thing that a PSE will do is detect whether a power device is present at the other end of the Ethernet cable. And this process is extremely important for the reliability and the safety of the system, because of course not every Ethernet device can allow almost 50 volts between two pair sets. So the detection process is really critical and important. So how it actually works, basically detection is an impedance measurement performed by the PSE, and a valid power device that requests power will represent or present a 25 kilo ohm resistance towards the PSE. and then PSE will try to measure the impedance. It does this by applying 2 voltages and measuring the current. And if he sees that the incremental resistance is 25K, it knows that it's a PD that's connected. So with this detection, the PSE can also know if no device is connected, because then it would measure an infinite or very high impedance. PSE can also know that just a normal Ethernet device is connected that's not PoE capable, because in that case, or the 2 modes will be either shorted, so very low impedance, or there will be kind of a termination between the pairs, and that termination resistance is in the range of 150 ohm. So it can also detect that, and then it knows, of course, that it's not allowed to apply power to that device. Also in detection, the voltage is limited to below 10 volt anyhow, and also the current is limited to 5 milliamps. So it's really safe that a PSE cannot destroy a non-PoE device. Then if the PSE has detected a power device, it goes to the next stage, and that's called classification. So as you've seen before, there are different power levels possible, and it's important that both PSE and PD have a mutual understanding about the maximum power level that's allowed in the application, because if the PD would go above the power budget of the PSE, it will result in a disconnect, which of course is something you do not want. So in general, for PoE now, there are in total 8 classes that are defined, and in the table you see the power levels that are corresponding with those 8 classes. So going back, so the first generation of PoE, the power class went up to class 3. Then you had 13 watts that was available to the power device. The second generation introduced the concept of class 4, which allowed the power level to go up to 25.5 watts. And now in 3BT, you can go up to class 8, which means the power level can go up to 71.3 watts for 100 meters of distance, or eventually 90 watts for short distances. And also 3BT, next to class 8, introduces 3 different power classes. So during classification, the PSE will actually probe what is the maximum power that the PD would need for its operation. It's also an important concept to know that even though if you want to implement a power device that would, let's say, need 70 watts, so that would be a class 8, you're not sure in front that the correct PSE is hooked up to that device. So every power device that would need more than 13 watts can also be powered up in what's called underpowered state, because if the power level of the PSE is only 13 watt, of course, drawing more would result in a disconnect, and the PoE standard takes this into account, that it does not want to allow sudden disconnects without the user knowing what is wrong. So basically, a 70 watt system will always also need to be able to power up with only 13 watts, but of course it will then not have full functionality, but it could only be a very basic functionality then, by just indicating to the end user that for having the full capability, he should connect the device to a higher power PSE. And this table also shows you what the fallback classes are. So again, if you only request or need 13 watts or below, then you do not need to worry because the basic power level you will be powered up with will always be 13 watts. But if you want have a system with more than 30 watts, this is something to consider. The requested class is always fixed for your design, so you only need to look at a few rows in this table. So for instance, if you would request class 8, it could be possible that you actually get assigned to class 8, and then you have your full power capability, but you could also fall back to classes 6, 4, and 3, which means you would need to operate or just indicate to the end user that you're underpowered. Then I'll give some more background of how classification actually works. It's kind of a state machine that is executed, and actually when the PSE rises the voltage to the classification level, which is between 13 and 20 volts, the PSE will actually draw a specific amount of current that is in correspondence with the requested class or with the actual power level that the power device would like to have. And by giving a number of pulses, actually the PD knows how much power it is able to draw. So basically the first and a third pulse are just for the PSE for probing the power level of the power device, and by applying a second pulse the power level is increased, and the same is the case with the fourth and a fifth pulse that's given. Next to the maximum power level of the PSE, there's also some other info that's exchanged now with the 3BT standard. First thing that's exchanged from the PSE to the power device is the amount of minimum power that the PD needs to draw, because besides a maximum power level, there's also kind of a minimum operating current, because if you would unplug the cable, meaning the PD is disconnected, of course you do not want to have the 50 volts still being applied across the cable, so a PSE will continuously measure the current and also check whether the power device is still present, and as a consequence, power device also needs to have a minimum current draw, otherwise it will be disconnected by the PSE. And also during classification, the PSE will now exchange what the minimum current level is that the PD needs to draw in order not to be disconnected. And then also in the 3BT standard, there's a new feature that is called Autoclass, and also during classification, the PD can inform the PSE whether it supports Autoclass. But I will go into further detail later on. So then when the detection and classification stages have finished, then the PSE will actually apply the full voltage across the Ethernet cable, so around 55 volts. But then still the power device needs to start up, and as you know, at the input of a DC-DC converter, there's always a large capacitance for EMI reasons. So also this is taken into account that this capacitor still needs to be charged when the PSE has powered up its port. So also in the PD controller, there's an Inrush circuit that will first charge the capacitor in a controlled manner so that the peak current is within the safe window of the PSE. And then when that capacitor is charged, the PD controller will give a power good signal to the adjacent DC-DC converter, and the complete PD system can then start. There's one thing to consider, but that's taken care of by the PD controller. So when in the beginning, when starting up, the power level is still limited to the class 3, and it's only after 80 milliseconds that PD can go to the full power class that has been assigned by the PSE. So just to wrap up, what happens when you connect a power device to a PSE with an Ethernet cable. You will see here in this diagram how the voltages and the currents would look like. So first, the PSE will be in the detection stage, where it will apply 2 voltages. There will be 2 corresponding currents, of which the PSE can detect the PD. Then the PSE will go to the classification stage. You will see a number of pulses, which will then correspond to the assigned power level to the PD. Then the PSE will power up the PD, so going to the full 54 volts. Then the PD will go into Inrush and charge its input capacitance, and then when that's charged, the system will start up. The microcontroller, of course, will also need to check what power level the PD has been assigned to, and then it can go to the maximum power state according to its classification. So this was the basic introduction of how PoE works, and I would now like to focus on the new features and capabilities of the 802.3 BP standard. So what's basically new with 3BT? Now with 3BT it's allowed to use what's called 4-pair power. So in the previous generations of PoE, it was only allowed to use 2 twisted pairs to transfer the power. And with 3BT standard, it's now allowed to use both modes or both alternatives at the same time to transfer the power. So as a consequence, it's already possible to double the power budget, because now both modes are used. Also for 3BT, they did further detailed analysis of how many power can actually be transferred over a cable, and they found out that it's even possible to increase the current level of each mode. And then finally, they fine-tuned the system that with a slightly higher PSE voltage, it's also possible to further increase the power budget. And when you combine those 3 measures, this results in a 3 times higher power level that can be delivered by the PSE. So instead of the 30 watts we had before with 802.3 AT, we can now go up to 90 watts. Then what are the benefits of 802.3 BT? Of course, most important is that the higher maximum power level is possible. So this will enable the implementation of a lot of new systems that can be powered by PoE. It will also increase the efficiency, because when using all 4 pairs, you can actually lower the cable resistance, so which of course will result in a higher efficiency. It also allows for a lower standby power. So now the standby power can be lowered to around 13 milliwatts only for up to class 4 and up to 20 milliwatts for higher power levels. So that's quite low. And it also will allow a better allocation of the PSE power budgets. And that's the new feature Autoclass, where I will talk about now. So this is an example of the use case, because as I told before, you need to request a certain power level. But for instance, if you would need up to 40 watts at the input, or more than 40 watt at the input, you would, instead of using class 5, you immediately need to jump to class 6, which is then 51 watts. And of course, a PSE always needs to take into account the worst case powering being 100 meter of Cat5 cable, so it would need to allocate 60 watts. But now with Autoclass, it allows the PSE to actually measure the maximum power the PD requires, and it can give a tighter allocation because a PSE a switch usually contains multiple ports, so the total output power needs to be divided between multiple ports, and by allocating too much power to one port, you could end up in an issue that it's no longer possible to power up the last port because not enough power is available anymore. So the benefit is more clear when you take into account if you would want to power 8 of such a PDs. So when using Autoclass, then the power level for that multi-port PSE would only need to be 350 watts, whereas for without using Autoclass, you would already need a 480 watt power supply. So from system point of view, Autoclass can give you significant cost savings. Then these are typical applications where power over Ethernet and then definitely the new 3BT standards would be used. It will be the default standard for powering small cell base stations. So for 5G, you need a lot of more antennas for covering the higher bandwidth. So, and then the antennas are powered by PoE. That's the main standard. Also for IP cameras, but then the more advanced ones, meaning the pan-tilt zoom cameras that include motors and eventually heaters for the camera. Also wireless access points usually only use PoE as power supply. There's also some exciting things going on for lighting to make the lighting more smart and power it by power over Ethernet. And then also all kinds of devices like a PC, a display, or a network video recorder can be powered by PoE with new power levels, whereas for 802.380 the 25 watt was a bit too limited. And another application is what's called a port extender, and there you have basically a PSE input and multiple outputs to power multiple devices. So up to now I've been talking about the technology, then I would now like to step to the products that you can use to actually build a PoE system. So this slide shows the ON Semiconductor portfolio of power over Ethernet PD controllers. As you can see, in total we have 11 devices, and you already can split them up into two families. First of all, you have NCP1096 family, which includes the PD controller as well as a DC-DC converter in one package. And next to that, you have a second family, that's the NCP1096 family, and that's just the PD controller. So with this one, you still need to put a DC-DC converter after it. And one of the main differentiators is always the power level for which you want to design your system. So if it's only up to 13 watt, then basically all of those parts could be used. But when going to higher power levels, the selection is a bit more restricted. But of course, it also has to do with the classification, which I have been talking about before. Then the two new devices to fully support 802.3bt are NCP1095 and NCP1096, and the basic difference between both is actually that 1096 has an integrated Mosfet, whereas with 1095 it's possible to use an external Mosfet. So I now would like to talk about NCP1095, or new 802.3bt PD controller. So it first of all fully supports 802.bt and power levels up to the 90 watts that is defined in the standards. It can cope with all everything related to detection and classification. It uses an external Mosfet and sense resistor. It uses a fixed inrush current, and the 1095 is available in a standard 16 pins TSSOP package. When implementing a PD, this is basically the schematic you need to add in front of your system. So with the PD controller, which is here NCP1095. So basically the only thing you need to do is select the appropriate resistances that correspond to the PD power class you want to implement, and that's given there in the table. And those two resistances will be connected to the CLA and CLB pins of NCP1095, and the other side components are just to support the PoE standard in general, and they typically do not change for other classes. So as you can see, you also need a rectifier bridge at the input, because the polarity of the voltage is not defined. So positive as well as negative voltages are possible. That's why a diode bridge is used. But when you go to class 8, instead of using a regular diode bridge, it becomes kind of mandatory to use an active bridge consisting out of MOSFETs, of which we have GreenBridge 2 in our portfolio. And as you can see with NCP1095, on the bottom you just need one additional external sense resistor and a MOSFET to complete the system. Then next to 1095 you also have 1096, in which the MOSFET and sense resistor are integrated. So basically you have the same features as 1095, and in fact both are also pin compatible, with the only difference that NCP1096 has an exposed pad. That's actually the drain of the internal MOSFET. And here's you see then how a system with 1096 is implemented. It's the same as with 1095, but of course here the sense resistor and Mosfet are integrated. Then what are the advantages of using the ON Semiconductor solution for 802.3bt? First of all, we have the lowest on resistance of the internal pass switch, which is only 17 milliohms typical at 25 degrees C. Overall, we can have the highest system efficiency. That's the combination of the GreenBridge 2 active bridge rectifier combined with 1096, so all with internal MOSFETs. And basically the power loss of the first stage, so bridge rectifier and pass switch, is extremely low because as you can see, the efficiency from the connector to the output of the switch is above 99%. So it will basically mean the total efficiency is almost purely determined by the DC-DC converter that's used behind 1095 or 1096. And then third advantage is that with 1095, but also with 1096, it's even possible to make a proprietary system that even pushes the power level to beyond 100 watts. Then, of course, we also have several reference designs and eval boards that allow you to easily design in our products and make a 802.3bt compliant system. So here you see the two demo boards we have. One is for 1095, that's on the left. The board of the 1096 is on the right. And basically it's the same demo board, same components. Of course, with the only difference that with 1095 you still have the external pass switch, which is highlighted there by Mosfet, whereas for 1096 you can see that that position is open. So that's basically the only difference between the two. And then what you need for having a PoE system is, of course, you always need the same RG45 connector. There's nothing special about that one. That's just the regular RG45 connector that you can use. There's no special constraint about that. Then you have the LAN magnetics. So those are used for providing isolation for the data, for the Ethernet data, and as well it gives you the center tap for extracting the power from the line. LAN magnetics need to be rated for the current levels. Manufacturers are Worst Electronics, Qualcraft, Pulse, Born, so a lot of manufacturers to choose from. And then you see there on the bottom right the two GreenBridge active bridges, and then in the upper right corner then you see the 1095 or 1096. And also our EVB has an output connector that allows you to connect the EVB to the DC-DC converter or to the rest of the end system. So this slide gives you some information about the GreenBridge 2. So that's the active bridge rectifiers that's used at the input. It's quite compact, so only 5 by 6 millimeters. And this gives you a thermal plot, so you can see that the temperature rise remains very low, and which is logical because it's an extremely high efficiency above 99%. And ON Semiconductor also has several reference designs for DC-DC converters that can be used for generating an isolated supply. So one of the controllers you can use is NCP1096 that implements an active clamp forward converter, and there are EVBs available for a 3.3 volt, for a 5 volt, and for a 12 volt output. and connecting the PoE board with the DC-DC converter is quite straightforward, as is shown below, and there's a specific design note that guides you to how combining both of them. Other typical application of 802.3bt or PoE in general is for lighting applications, and in that case usually it's a non-isolated approach that's being taken, so you just can use a regular buck converter to generate a 3.3 volt to power the microcontroller, and then the LED driver can be powered directly from the PoE input voltage. But of course you can build more advanced systems like a complete pan-tilt zoom camera. So here you have an overview of what components of ON Semiconductor you could use. This is based around NCP1083, which is a DC-DC controller and PD combined. It generates a 12 volt that it's used directly to drive a stepper motor, and also there's an additional buck converter that generates 5 volt for the remaining of the system. So then, to wrap up, I would just like to guide you how you actually implement 802.3bt on your new products, how you can select the appropriate PD controller. So these are the 5 steps you basically will need to go through when designing your system. First of all, you need to determine the maximum power level that you will need in your application. And as you know, there are 8 power classes defined in Power over Ethernet. So then you need to choose a specific class you want to use. Next to that, you need to gather some additional information, whether you need an isolated DC-DC converter or not. If you want to have support for an additional auxiliary supply, what the standby power is, or the minimum standby power if it needs to be extremely low, or if you would want to support Autoclass. And here one of the main questions is whether you need isolation or not. But whatever your choice is, you need to take into account that the Ethernet lines always need to remain isolated with respect to ground of Earth. So if you have a floating system, you can use a non-isolated DC-DC converter, but usually an isolated DC-DC converter is used. So then you will fall into basically 3 options, or you implement up to class 3, in which, or you implement class 4, or you implement class 5 to 8. And then the next slides give you an overview of which ON products can be selected for designing your 3BT system with the PD class you've chosen. So let me now step. So in case of if you have a system up to 13 mod, basically all the PD controllers could be used. If you have a system and you want to implement class 4, you have these 6 parts that could be used, either 1081 and 1082 with integrated DC-DC converter, or 4 of the NCP1096 families. And if you want to implement a class 5 to 8 device, then you have the choice between NCP1095 and 1096, which I already covered before. So this basically brings us to the end of the presentation. I'd like to thank you for your attendance.
We'll round off the seminar here. If there are any questions, you can of course contact us or the partners for the presentation, and we will get back to you in more detail. So thank you all for today.